is on radicals. And we have done radicals before. You guys remember when we
broke them down?
We broke them down? Yeah, I had to decipher what you just said. We're going to learn how to graph the function of a square root. I want you to take this down. So our learning target says I can graph a square root function. That's what we're going to be able to do by the end of this class period. Is everybody ready? Okay. Why don't you move over here? So you're not a weirdo. Move over.
You get on my nerves.
No, but I'm graphing. We're going to be graphing. You can. These are easy to graph, so you can graph them on lined paper. All right, so square root functions. This is what it is. This is our parent function. This is the base function, the alpha, the omega, the beginning, and the end. Okay, this is where all the other functions start and flow from. Does everybody understand?
Yes.
Just like our parent function of our quadratic was x squared, just the base one. This is just the square root of x. So to take the square root of something, you know you'll get decimals if you don't plug in a perfect square, right?
Right.
So we are going to plug in perfect squares. We're going to make a t-chart. That's what we're going to learn how to do first, and then I'm going to teach you how to graph it in vertex form. It's real easy. So we're only plugging in perfect squares. The first perfect square we're going to plug in is 0, then 1, then 4, then 9. And we're going to plug those in for x, and we're going to take the square root of them. So plug in perfect squares for x. Okay, so let's plug in 0. What's the square root of, bless you, what's the square root of 0?
0.
Alright, let's plug in 1. What's the square root of 1? Alright, let's plug in 4. What's the square root of 4?
16. Whoa, I wasn't thinking. I wasn't thinking.
We're taking the square root, and then the square root of 9 is 3. Does everybody see where we got those numbers from?
Yeah.
Okay.
If I need how much of a struggle
I don't love that. But that's just been this kind of day. Alright, so then we're going to create a graph. This is x, this is y. And all we're going to do is we're going to plot our values, and then we're going to talk about the domain and range. Now it starts at 0, 0, so we're going to put a dot on the origin. And then it's 1, 1, so we go right 1, up 1. 4, 2, so we go right 1, 2, 3, 4, up 2. 9, 3, so we go right 9, up 3. And then we connect them. Now, can we ever plug in negative values into a square root? Or can we, let me rephrase that. Can we take the square root of a negative number? No. So it will not go to the left unless we manipulate it. Okay?
What happens if you do plug in?
It's imaginary. It doesn't work. Let me show you what it looks like on the calculator.
Yeah.
So if I take the square root of negative 4, domain error, which means it can't work. Alright, so now our domain, which it says over here, is x when x is greater than or equal to 0. So we have any x value as long as it's greater than or equal to 0. And that's what we plugged in, right?
Yeah.
Now our y value, our output, it went up. So our y value is also y when y is greater than or equal to 0. And that's it.
What are we doing after this? What if there's a number outside?
We're going to talk about that. It's going to be magic. So So that is our base form, and then just like we had vertex form with a quadratic, you see how it looks very similar? You have the same thing, except it's square roots. So your HK is your vertex, so it's the opposite of H and K are your vertex, which is your starting point. And then from there, you instead of going, you remember when we did vertex form, we would go up the perfect squares, then left or right the square root of it?
You're doing the opposite.
You do the opposite. You go right the perfect squares and up the counting numbers. So this time you'll go right 1, 2, not 1, 2, 1, 4, 9, 16. And then you go up 1, 2, 3, 4. Now, this looks like half of a parabola turned on its side, right? That's exactly what it is. And the rules of A still apply. So if A is greater than 0, it's going to be a thingy that looks like this. And if A is less than 0, it's going to go upside down. Magic. Bless you. So now we're going to learn how to graph by using the table, and we're also going to learn how to graph from vertex form. You just plot the vertex, which here we didn't have anything on the inside or on the outside, so we started at 0, 0, and then we went right 1, up 1, right 4, up 2, right 9, up 3. That's all you do. So if it was plus 2 on the inside, remember it's the opposite, so you'd move left 2, put your dot, and then right 1, up 1, right 4, up 2, right 9, up 3. That's it. That's all you do. Are you ready to see what happens? All right, 63B. B is in potato. All right, graph each function. So we're going to figure out how to move it left or right first. Is everybody ready? No, I said the x value, you can't plug in negatives unless we manipulate it. No, we're not going to go left or right first. We're going to go up or down first. No. Nope. That was only for the project and the test. Now it's mine. You can use lined paper. These are easy to graph. Are we ready?
Yes.
Okay. Now you can do it two ways. You can do it from the table, and then you can also do it from... Why are you making that weirdo face? Why are you confused? I haven't even started explaining. Alright, weirdo. Didn't know what was happening. Okay, so what we're going to do first is we're going to plug in our perfect squares. Now, can we plug in negative numbers? No, because this minus 4 is on the outside. This is the square root of x minus 4, not the square root of x minus 4. They're two different things. So we're going to start with 0, 1, 4, 9. So then we plug in 0. What's the square root of 0?
0.
What's 0 minus 4?
4.
Magic.
Whoa.
Now let's plug in 1. What's the square root of 1? What's 1 minus 4?
3.
Magic. What's the square root of 4?
2.
And what's 2 minus 4?
2.
And what's the square root of 9? And what's 3 minus 4?
1.
Look at that. ready to graph?
Yeah.
Let's go crazy.
Wait, are we always going to use 149, 0, 149?
Yes, unless there's stuff on the inside, and we're going to talk about that.
Whoa.
Do you need help? Are you being attacked out there?
I think you just.
Alright, so we ready to plot? Yes, no, maybe?
World domination.
Alright, 0, negative 4. So we don't go left, right, any, and we go down. 1, 2, 3, 4. Put a dot. Is that my starting point based on my equation?
Yes.
It is, because we don't have an h, so that's 0. And minus 4 would go down 4. Alright, then 1, negative 3. Write 1, down 3. 4, negative 2. Write 1, 2, 3, 4, down 2. And 9, negative 1. Write 1, 2, 3, 4, 5, 6, 7, 8, 9, down 1. Magic. Do you understand now? Now that you gave me like all of 5 seconds to explain it? Alright, now, you can also use vertex form to graph this and not have to use the table. So since you know that there's no h, that means it's going to be 0, negative 4. So you would just go down 4. And then you would go right 1, up 1. Right 4, up 2. Right 9, up 3. Boom, you're done.
I like that.
It's so much fun. I love it.
The next time.
You would plot your vertex of 0, negative 4. And then you would go right 1, up 1.
Oh.
Right 4, up 2. Right 9, up 3. Now let's talk about domain this time. Domain and range. Now, are any of our x values below 0?
Yeah.
X values. No, we started at 0, right?
Right.
So it's x when x is greater than or equal to 0. What about our range?
Yeah.
What's our range?
X.
It's y when what?
It's Y when.
No, it's going up. Greater than or equal to?
0.
Where did it? Y did not start at 0. It started at negative 4.
The third period, you get that one?
Yes.
We gotta do that now.
Y'all ready? Now, if out of
Oh, yeah.
if we're subtracting 4 on the outside and that moves it down, how could we move it up 3? We would add 3, yes. Now, what if I wanted to move it left or right? Where would my number have to be? Inside the radical. In front of it stretches it just like it did with x squared. Ready?
Yes.
Let's do this. Tater tots. Let's graph this next problem. I should not drink that coffee. It's getting me wired. But
I'll
it's
drink it.
better wired than going to sleep, right?
No, I think I can drink it.
No. Alright, we're going to do the square root of x plus 3. Now, I'm going to show you how to graph it in vertex form, and then I'm going to show you what the table will look like, okay? Now, we know that our vertex is HK.
Right.
It's the opposite of whatever this is and whatever number's on the outside. So what would our vertex, our starting point be here? Negative 3, 0. Yes. Negative 3, 0. All right, let's draw our graph. All right, and let's go left 3. What do I do from there now?
Up 1, 2, to left, to right.
Right one up one.
Right 1, up 1. And then?
Right 4, up 2.
And then?
Right,
Right. Right 9 up 3.
Right 9 up 3.
And if I wanted to keep going?
Right. 6, 4.
Yep. And then 25, 5. And that's it. Look at that.
Ready after me.
Somebody have any questions on how we got that before I show you the table?
How did you figure out the negative 3, 0?
Because our vertex is always the opposite of whatever is in here, and then whatever's on the outside. So since it's positive 3, it's negative 3, and there's nothing on here, that makes it 0. Good question. What? I'm going to show you. The table, you mean? You think you mean that? Okay. Hey.
Hey.
Thank you.
Hey, I love you.
Alright, so for your x values this time, we can't just plug in any number, right? Because under the radical, we want to be able to get our perfect squares. We want to get 0, 1, 2, 3. So when you have, 0, 1, 4, 9. So when you have something under here, you have to figure out what numbers you can add to it to get 0, 1, 4, 9. So what number can I add to 3 to get 0? Okay. What number can I add to 3 to get 1?
Negative 2.
Alright. What number can I add to 3 to get 4? And what number can I add to 3 to get 9? 6. Now those are also the values here. Now I did that because I want to get a perfect square under the radical. Negative 3 plus 3 is 0. The square root of 0 is 0. Negative 2 plus 3 is 1. The square root of 1 is 1. 1 plus 3 is 4. The square root of 4 is 2. And 6 plus 3 is 9. The square root of 9 is 3. And that's what we did. Yeah. Now, what do you think would happen if we had a number on the outside?
Shift it down.
But doesn't that
Feels
make it
negative.
graphic?
For what we just did, or if there's a number on the outside?
What we just did.
No, that's the same thing.
But when you go over 1 up,
Right 1 up 2. Right 1 up 2. Left 2 up 1. Same thing. Because you start from the origin when you plot your points.
what about that 6?
Right 6 up 3. That's this. Because you start from the origin when you plot your points, not the vertex. When we use our perfect squares, you start from the vertex. Alright, so we are now going to do one that has a number on the outside. We're going to say f at x equals negative 5 times the square root of x. Chaos, right?
Really?
And then we're going to go back and talk about our domain and range of b and c. Alright, negative 5 times the square root of x. Now, do you think it's going to stretch that graph, or do you think it's going to make it flat?
Was negative 5.
Stretches and it's on the outside? Okay. Maybe. I like it. We'll see. Alright, let's plug in variables. Alright, we're going to use our perfect squares again because we don't have anything under the radical. So we're going to use 0, 1, 4, 9. Alright, what's the square root of 0? And what's 0 times negative 5?
0.
That should not take us that long. Let's try that again. What's the square root of 0?
0.
And what's 0 times negative 5?
0.
Alright. Let's plug in 1. What's the square root of 1?
1.
And what's 1 times negative 5?
Negative 5.
Okay, thank you, zombies. What's the square root of 4? And what's 2 times negative 5?
Negative
And what's the square root of 9?
10.
And what's 3 times negative 5?
Negative 15.
I think it's gonna be flat.
You think it's going to be flat? Okay. Let's graph it and see. So we have 1 vote for stretch, 1 vote for flat. Anybody else want to weigh in?
I'll do flat.
You'll do flat? You'll do stretch? Let's see what happens. How many votes do we have? Okay, you would think by now in my teaching career I would know how to draw a straight line. All right, how many votes do we have for stretched? 1, 2, 3, 4, 5, 6, 7. How much? 8. How many votes do we have for flat? 1.
I meant stretch. I want to say stretch.
No, you can't change it. You can't change it.
Well, I got a better insight. I was like, that's a Raven. Because
Nope.
the X values aren't negative. But I was thinking it was going to
What are
go
you
this
doing?
way. But the X aren't negative, so
No.
it's going to be stretched.
Really?
Sheet of paper.
No. You have to use a regular sheet of paper.
I just need a sheet of paper.
You just need some paper because you didn't come to class prepared. I bet you remembered your cell phone today.
I did. Come to class practice. I just feel like getting it out of my mind.
No.
It's going to be stretched. No, it's
No, you can't change your vote.
Well, John, you're right.
Y'all ignore her. All right, 0, 0. All right, and then we're gonna go right 1 down. 1, 2, 3, 4, 5. Right 4. Down 10, 5, 6. And right 9. 2, 13, 14, 15. What did it do to it? It stretched it. What do you think? If a whole number stretches it, what would it have to be flat? A fraction. Or a decimal. Yep. Now, do you also notice that the negative flips it upside down? And isn't that what we said before? In the beginning? In the beginning, Asbury said the negative 8 flips it down.
What is that? Wait, what's your dog's name? The first one. The first one you got.
Gambit?
Gambit? Okay, so that's Gambit. What? Gambit, Thor. You said Thor. What?
What are you talking
This
about?
knows Genesis 1. Just be.
Okay. Alright, now, you can still do this in vertex form, you know, where we were going right 1 and then up the counting numbers, right 4, up 2, right 9, up 3. You can still do that because you just multiply this number by the counting number. So we still went right 0, 1, 4, 9, but then you multiply that negative 5 times 2 and 3. So you can still do it in vertex form. Alright, you need 8 colors. Wait, no, pause. Domain and range. What is the domain of this graph? Did we plug in any negative numbers for x? No. So it's x when
X is no greater than or less than 0.
because we didn't plug in anything less than 0, did we? And for x.
I still don't know my greater than or less
I'm going to pretend like you didn't just say that to me. Alright, and our range. Now, what did our y value do? It went down. So is that less than or greater than? So y, when y is less than or equal to 0. Magic. Now let's look at our domain of this guy, of b. Did our x values change this time?
They went negative.
They went negative. So it's x when what?
Less than when they are less than.
Did we get less than negative 3 on our x-axis, or did we get greater than negative 3?
Yes.
Greater than or equal to negative 3. What about our range?
Y is greater than 0.
Alright, now you're going to need 8 colors. 8. An S and then a 2. Pardon? Yeah, I can do whatever.
What by
Where's Andrew? He broke his finger.
Yeah.
Well, what broke his
Already.
They know the first practice. I break it. Do it to him.
No, I coached it to him. No, I coached through it to him. Were you at one of the LA students? They're both coaching.
Yeah.
Ellen and Walton.
Maggie, go to sleep.
Yeah, I think they went a little bit crazy. What did you hand that back to her?
No, she put it on my desk and it's empty.
Oh.
But she still used it because there was so much. No, I did not. Here, I'll take it here.
I'll go there.
Dakota was signing to go to Montevallo on cheerleading, so I went to.
Can I do this? Wait, which one marks the sharpener? The blue. You need 8, I know.
Yes. Alright, we ready? So what I want you to do with your colors is I want you to outline the arcs in the different colors. Because we're going to have to match up the equation with the graph, and we can't do that if we don't have them in color. They were originally in color, but you know the copier only copies in black and white.
What happened to the copier?
It made copies?
I don't know. I thought something happened like.
Christine! What is happening over there, babe? Okay. No, ma'am.
Yeah, I feel like I'm about to be saying
Hey, babe.
That's my favorite.
What? Your diagonal neighbor.
You're basically my neighbor at the table.
That's my favorite.
Oh my god.
Michael,
Get out, I'm having class.
we're double neighbor.
Thank you for bringing that. I love that kid. What are you doing? It's the white one.
I don't know how to turn the line.
Me either. But persevere in the face of danger.
What's that? Gambit. 1, 2.
Yep.
Get it.
Are we ready?
No, I have one more line. I did it. I'm done. I don't know.
Yo, we just tracing lines.
We built it. Go.
No.
I feel like that wouldn't work. I'm done. I'm 8. Uh-oh. They went through on the back. I didn't know we had a back.
Who's it?
None of your business. I don't like him.
We ready?
I'm gonna be like depressed on Thursday.
What are we doing on Thursday? The talk show. That's this Thursday? Oh. Oh, wow.
Oh, sweet potatoes. All right. We are matching up the function at the bottom to the graph. So the first function is the parent function, y equals the square root of x. Now, based on my colors, which one do you think that is? Do you think it's this red one right here that's moved over?
No.
Do you think it's this light green one? Or that's brown? Do you think it's this orange one?
It has to start with
It has to start at 0. So it could be one of the ones that starts at 0. Now, it's either going, this orange one is stretched. That's not what our parent function looked like.
The green.
The green, the dark green. Yep. That is our parent function. Because it passes through 0, 0, it passes through 1, 1, it passes through 4, 2, it passes through 9, 3. Alright, what about B, negative square root of x? Which one do you think that is? The red one, the same one but flipped over. Alright, now we did one. C says the square root of x plus 5. And we did one where it moved over, and plus 3 moved it to the left 3. So what would plus 5 do?
To the right, I mean to the left 5.
To the left. So which one is that?
The white part.
This one.
Oh, mine's orange. Sorry.
Because it moved it to the left 5. Does everyone understand? It went from the origin to the left 5. Alright, so what would minus on the inside move it to?
To the right.
To the right.
To the right 5. So that's that brownish color.
Looks like dark green.
This one?
Yeah. Oh no.
Yeah, like a brick, but it's this color. It's kind of pretty.
I use that color.
It's not really though. Look at it under the.
Oh, never mind.
You're not saying it.
Are you keeping it?
No, I'm gonna figure out
Oh,
what color it is.
okay. All right, now the square root of x plus 5 on the outside. So when we did minus 4 on the outside, it moved it down 4. So what would plus 5 on the outside do?
Down 5. You just said it was down 4.
Up forward. Up five.
Up 5, yes.
Okay.
Thank you. So that would be that hot pink color. Alright, so what would minus 5 on the outside do? Bring it down. And that's this blue. Now, our last two. We have to decide between a whole number and a fraction. So what is a whole number going to do to it? It stretches it. So is that this flat one, or is that my orange arc?
I mean, oh my gosh, I'm not.
You'll get it.
I'm meaning to say it, but it's going the opposite way.
Okay. And so then that leaves our last one, and you guys asked what the fraction would look like. That's what it would look like. Have you figured out what the color is yet?
I'm saying it's a light brown or the dark beige.
A dark beige.
That sounds like it. That's what I like.
Look at the lyrics.
Oh my
God.
God.
In class. Look at those lyrics.
I'm not a boy. Don't see my kid.
You have any questions? Alright, now at the bottom it says describe how each variable transforms the parent function. And you have an A, you have an H, and then you have a hole punch where K should be. So what I want you to do right now, and you're welcome to talk to each other, I want you to tell me how A, the number out front when it's in vertex form, changes the function. I want you to tell me what it does. I want you to write it down. You can talk to each other. You cannot talk to me because we've already talked about it 4 times. Yes, steeper is more accurate, not steepens.